Welcome to Black Hat Windows 2K Security, held February 14th through the 15th, 2001 in Las Vegas, Nevada. The following videotape was recorded live at the conference and produced by the Sound of Knowledge Incorporated. This is videotape number 6C, a continuation, Deep Knowledge Track, IPSec in a Windows 2000 world.
IPSec end-to-end. So we've got 2 folks, 3, 4, 5, 6, 7. Okay, that's great. I'm glad you're here. All right, so where we are in the agenda, we're at the Win2K IPSec and deployment. William doing 2:30 to 3:45. I will finish by 3:45. After that is the demo, and Dan and Raymond are working on demonstrating either tunnel mode or transport mode between 2 systems doing peer-to-peer wireless. Nice thing about the 802.11 standard that allows peer-to-peer. Okay, so I'm going to talk about L2TP first. Am I coming through on the mic? It's on? Okay, it's fine. Oh. How about now? Okay. Jeez, I can hear myself and I'm echoing and I think I'm on. All right, so I want to talk about L2TP IPSec so you understand how it works and we can talk about deployment issues. If we have time, I'll go into the IPSec end-to-end deployment. Okay. As I mentioned earlier, Cisco and Microsoft and a bunch of other people wanted a standard for remote access for basically PPP-based remote access. There's an enormous number of people who still dial into the internet, and they wanted to enable a business for VPN. And PPTP is what, as I said, Microsoft shipped for all platforms in 1996. In 1998, Bruce Schneier published some security review of it that found that it was pretty weak originally in terms of how it treated the user password hash. So we updated PPTP in 1998, the same year, and released Done 1.3, which had all the fixes in it. And to my knowledge, and I believe Schneier's paper that's still published on his website says while the improvements, I can't remember the exact wording, but basically while the improvements are necessary to overcome the prior weaknesses, PPTP is still as secure as the user's password. Okay, so the bottom line is there's an MS at the most secure configuration of PPTP, except in Windows 2000, we'll talk about that. The most secure version of PPTP that involves a user's password uses the MSCHAP v2 hash, and there are tools like Anger 1.33, which is published out there. Security Focus, Insecure has it, everybody. Basically, that will be able to take a PPTP hash out of a sniff and party on it for password guessing. So PPTP for your remote access clients is still as secure as their password. And we want to make sure everyone's aware of that. So strong user passwords are required. And by strong, I mean random 14-character strings. In some cases, I guess I'd rather have it on my wallet or something written down so that I can actually type it in versus connecting across a public network, somebody sniffing it, and now my corporation's compromised because I used a weak password. So if you look at the support in the industry, the options today that Microsoft ships, this is not necessarily everyone shipping, but the VPN client that Microsoft ships for Windows 95 is Done 1.3. I believe there will be a Done 1.4 coming out in a couple of months. It's been in the works for a long time, and I'm not sure what its release status is. But basically, it has the strongest PPTP version. It's been out for many years, but all your users should be using Done 1.3. Same thing for Windows 98, Windows 98's second edition, Millennium, and then NT4. All of those have PPTP, essentially as the VPN protocol. Windows 2000 is a whole different animal. And we spent approximately 5 years developing Windows 2000, 3 years developing just the VPN and IPSec capabilities of Windows 2000. And so basically, because PPTP had some limitations, we wanted to go with and it wasn't an IETF standard per se through a working group process. We wanted to go through an IETF standard VPN remote access protocol. So primarily because of the features in PPTP using PPP-based tunneling and Cisco's layer 2 forwarding, we got together and formed the L2TP Remote Access Protocol. We'll talk a lot more about L2TP in the next slide, but the bottom line is that Windows 2000, so in the IETF, when they created L2TP, they specifically said when L2TP runs across the internet, it will be carried by an IP packet. And typically in the way IETF working groups work, they don't define a new security protocol if another group is already defining security. And in fact, the IP security working group was defining security for any kind of IP packet. So clearly the L2TP guys said, well, if L2TP looks like an IP packet, then use IPSec to secure it. And we thought it was pretty straightforward on how to do that. It turns out that the way L2TP is designed, it's not at all straightforward, given the way that IPSec is designed. So I'm the co-author, along with Skip Booth and another guy from Intel, Baiju Patel, and another guy, who I forget right now, Glenn Zorn, I think, also with Cisco, on the L2TP IPSec security draft. That's a draft, and we've been working on that for the last 2 years. So we do not support that draft in Windows 2000. We do something as close as we could and as interoperably as we could at the time we shipped. So the top level picture that this slide shows, you have a number of VPN gateways which will accept PPTP or L2TP. Cisco's iOS product. Cisco now bought, since this slide was created, Altiga. They bought compatible systems. They have PICs, firewalls that also do VPN. They have a bunch of VPN products. So basically, Cisco has a bunch of products, almost all of which I think support PPTP. They do not all support MSCHAP v2. They may support only MSCHAP v1, in which case you are SOL against the password guessing attacks. SOL in the sense that if your users have weak passwords, which I guess we'll assume that they do. So be careful. Even though you are using a particular product in your remote access solutions today, you need to make sure that it supports MSCHAP v2 to get the strongest password-based security. All right. So if you don't have PKI, I mean, the whole IETF solution to user authentication in the internet was PKI. And as some of you know, it's been fairly difficult to deploy PKI. If you have a PKI, then you have two options in Windows 2000. If you don't have a PKI, then basically what Microsoft provides is PPTP, and you're back to strong passwords and MSCHAP v2 requirements. Okay, so if you have a PKI, in Windows 2000, PPTP was enhanced, in fact, PPP in general. So dial access as well as VPN access that uses PPTP was enhanced to support something called the Extensible Authentication Protocol, EAP. EAP also has a form that it does TLS, right, which is basically SSL inside a user authentication request. That's RFC 2517, I think. Anyway, both EAP methods that we support are RFCs. The benefit of using EAP inside PPTP is that you can relieve yourself of the burden of password hashes on the wire. So if your user has a certificate, either it's on a smart card or the certificate lives on the computer disk, right, as part of the user's laptop, then they can use PPTP with EAP authentication. What will happen in there is that when you launch the PPTP connectoid, it'll prompt for the user certificate. The user selects the certificate, and away they go. Okay? This support is also in L2TP for user authentication. This is certificate-based user authentication. All right? It's also in normal PPP dial. If you're remote, if Cisco's 5300s and others, or any of the dial access points that the ISPs have deployed, if they have upgraded the software and have an EAP compliant PPP stack, then you could also user authenticate with certificates everywhere through all uses of PPP. So that we consider is a substantial improvement to PPTP. So it's not fair to say now that PPTP is just fundamentally insecure because of the password issue. It's fair to say that in Windows 2000, PPTP can be used with user certificate authentication in an RFC compatible way and be, I'll say, reasonably secure, or at least secure against the password guessing attacks that are the greatest vulnerability. L2TP can use, as I said, user certs for authentication, but because it's an IETF standard and because the standard way to secure IP traffic in the internet is to use IPSec, IPSec will be done first before L2TP ever authenticates the user. So IPSec has got to authenticate itself, which is the machine, before L2TP gets a chance to authenticate the user. Okay. Yeah. Yeah. EAP, the question was, is there a connection between EAP and the user certificates? EAP is what enables you to use something other than a password for user authentication. I'm sorry, I probably am throwing lingo faster than people can absorb, but EAP enables you to use some other user authentication mechanism other than passwords. And so that other method, in this case, is a user certificate. Also, I'm sorry, it also will enable Secure ID. Right? You can do Secure ID through EAP as well. This is for any use of PPP in Windows 2000. So it's VPN certainly for PPTP and L2TP. It's also for dial. It's just, when you're building the operating system, people know the operating system's not going to be out there in the market for a while, so the vendors typically delay their adoption of new features until the operating system's out there and people can turn it on. They also know that in terms of their development priorities, how many people have existing user certs deployed? Very few. So of course, they'll support it over time, and we wanted to get it in the operating system. We made a huge effort and also interoperably tested it to get it out there so it's just there in Win2K, and as long as Win2K lives, people don't have to do password-based authentication anymore. Okay, so L2TP actually is designed to do many things, and this is the benefit partly of going through the standards process is that it doesn't just do client remote access. It was actually designed to concentrate normal PPP dial systems, right? So the value to somebody like Cisco is that they can build what's called an L2TP access concentrator, and the access concentrator can live at the dial point, at the ISP dial point. It'll take existing PPP connections, and by basically smartly working with the PPP negotiation, it can forward the PPP negotiation actually end to end. All the way the PPP negotiation ends up happening partly to the LAC, but then also to the what's called the LNS, the L2TP network server. Right? This is the VPN gateway, the corporate VPN gateway. So as far as the client is concerned, he's doing a PPP dial session with his ISP. But what's actually happening behind the scenes is that this is securely tunneled across the internet, and it results in a VPN tunnel into the corporation, okay, or into the wherever you're tunneling to, all right?
Similar to L2TP.
It has, yes. In this sense, from the standpoint that it's providing a tunnel across the quote internet, it's similar to L2F, right? It's just a different protocol, and it does UDP 1701 encapsulation. Okay, so this is a way that down-level clients can be secure from the point of presence, from the POP dial server across the internet back to the corporation. And how do they know where to tunnel to? Because the LAC does get the user a request for user authentication and can actually authenticate the user. So he knows who the user is, and the user's going to say, I'm wdixon@microsoft.com. So it knows the @microsoft.com. It goes and looks up the VPN server, or it has some configuration for what VPN server to go to at Microsoft.com, so it can basically reset the PPP negotiation on the client and forward all that PPP traffic directly through L2TP into Microsoft.com's VPN server. Very useful. Notice no client changes, right? So this allowed them to basically sell services in the network, secure tunneling VPN services, virtual private networks, to companies that have all the existing dial clients, okay? The key point to realize is that the PPP negotiation is actually happening all the way between the LNS and the end system. It's just forwarded through an L2TP tunnel. Okay? And the security in this case is between the gateway and the LAC, right? That is the IPSec security here. So the gateway has to know how to trust all the LACs, the access concentrators. Okay, the other scenario is what we support, the way we saw value in L2TP, and that is to replace PPTP. From a client here, the client is going to do IPSec from the client. Well, first of all, you're probably going to establish a PPP dial session with your access provider, or you might be on broadband. You could be just on the network, right? Or just plugged into the internet somehow, right? At a conference or airport over wireless. Somehow you have access to the internet, and through PPP, you got assigned an internet IP address, right? So using your internet IP address, you're going to negotiate IPSec and authenticate from your client credential all the way back to the company VPN server. So this is the way I do remote access. I authenticate, my client authenticates with a certificate to the gateway authenticates back to the client with a certificate that the client knows how to trust. So now we have an IPSec secure channel using the internet IPs of each side. Now I still have to authenticate the user, right? All I've done is establish a trusted encrypted channel. I'm still going to use L2TP to talk over here and basically a PPP negotiation so that this guy knows who the user is and can allow him into the network. He can also assign an address back to the client, an internal address, right? The classic thing we know about VPN. Okay, and then L2TP is also useful for just gateway-to-gateway tunneling, right? It appears as a routable interface on both of these systems, or in all of these systems, and as a routable PPP dial-on-demand kind of interface. It's very well understood, very easy to support for gateways, and traffic comes in, it gets routed to that routable interface, gets pushed across the tunnel and into the destination network. So the security in this case is between two VPN gateways or two firewalls or whatever supporting L2TP in this case. But all, via the routing, all traffic that's supposed to go through the tunnel goes through the tunnel. And the security is underneath and transparent to the end systems on either network.
So I understand that you have to use the hardware service to read
Yes, you're using a machine cert to authenticate IPSec, wherever IPSec is shown up there, the red basically, to do IPSec, and then you're using a user credential, be it password or via certificates or secure ID or whatever, to authenticate the user. In this case, you're not authenticating the user. In the gateway-to-gateway case, you're just connecting networks, right? But it would be machine certificates between the LNS or the firewalls or the routers. Okay, so this just says that Windows 2000 can perform these roles, which is basically all of it can be a dial server for the NAS. It can do gateway-to-gateway L2TP IPSec. It can be a VPN gateway for remote access clients as an LNS. It can be the client, if you will, for remote access. What it does not do is this funky PPP proxy, essentially, as an access concentrator. But again, Redback and Cisco and other people have already built those. Okay, this talks and gives you all the RFC information about PPP and our ability to do EAP. So in PPP, right, several authentication mechanisms, PAP, CHAP, MS-CHAP, they're all, PAP is clear text passwords. MS-CHAP and CHAP are all subject to password guessing. MS-CHAP v2 also subject to password guessing, but it takes a lot longer to do because of the length of the hashes are much longer. It's more difficult to verify. There's more things involved. It's an informational RFC 2759, published January 00. Okay, the Windows 2000 adds EAP, right? So there's the EAP RFCs, and those are standards track RFCs. So what you get out of PPP, of course, are the ability to tunnel any kind of traffic. We still have a lot of folks doing IPX in small business, right? You can do IPX across an L2TP tunnel. Again, our goal was to replace PPTP. What could PPTP carry? Everything PPP could carry, which is all protocols. So whether it's AppleTalk or it's IPX or IP or some other custom protocol that wasn't IP, it'll all work across PPP, and L2TP will carry it. So with basically one choice of a VPN protocol, I can get all of the traffic, and NetBUI, let's not forget. I can get all of the traffic that I needed to get through a VPN tunnel. So This really enables small businesses in particular. If you set up a Windows 2000 server as a VPN server as a small business, it really doesn't matter whether they're using NetBEUI only or NetBIOS for resource discovery and communication and sharing and all that stuff on their little internal LAN. They can have a VPN and get access to their internal LAN. They don't have to do anything special. Whereas other remote access solutions that are IP only, they only work with IP. So if you've got a small business using IPX for internal network sharing, they can't use that. Okay, most enterprises just do IP, so that's their market. Data compression, MPPC, the Microsoft point-to-point compression, is pretty much the industry standard, and it's informational RFCs there. Data protection, the Microsoft point-to-point encryption is done in called MPPE, and the way that it's done and the revision to MPPE based on Bruce Schneier's comments are all published in drafts. Okay, so that's basically how PPP protects. Now, when IPSec is being done to protect L2TP and the client knows about it, it doesn't have to do PPP encryption. It still does PPP compression because that's still useful because IPSec's not doing the compression. Right? So if you wanted to compress your packets to get them through the quote dial of the VPN link, PPP will do the compression. You could turn it off, and in gateway-to-gateway VPNs, it may be, because compression's being done in software, you probably want to turn off software compression. And there are options to do that in the UI, even for VPN clients. Okay, questions about PPP? Just an incredibly well-known protocol. It was just a great thing to leverage because everybody's got the infrastructure for it.
There's a question about after you connect to PPP and then you do the L2TP IPSec connection. By default, does Windows 2000 allow you to continue your connection to the internet, or does it drop internet connection and only allow you to VPN connection?
Okay, when the VPN tunnel interface finally comes up, it plumbs a default route down the VPN tunnel, and that cuts you off from the rest of your internet connections. So, right. And that was, without the ability to push routes to the client from the VPN gateway or have some policy control, that was our best default behavior. I realize a lot of people want split tunneling, and I have an equal number of customers that have very strong security requirements that say no, right? No access to the internet. They want to even plumb filters, right? To just absolutely cut everything else off when that VPN tunnel is connected because they're afraid of a proxy, like an application layer proxy doing something. So they want to guarantee the no other access except traffic through the tunnel. We partially get there, and you can programmatically get there with Connection Manager. So here's what we were trying to describe earlier with that flow diagram, how L2TP packets look on the wire. Let's first go through the top points. So it's designed, the L2TP tunneling protocol was designed as part of what's called the PPP Extensions working group in the IETF. Combined both PPTP and L2F, came out as an RFC 2661 in August of '99. Now, because L2TP is its own RFC and people are so excited about it, they're doing a lot of work to improve it, to optimize it, there's a whole other working group called the L2TP Extensions working group that's going on. And so you see everybody who's in the dial access business in that working group. One of the key distinguishing features about L2TP is that it does in-band control and data. So it does control messages, and it has a way of overlapping control messages with data messages. So it really can do in-band, while the data is being transmitted, optimizations on the tunnel. So it uses, all of this happens over UDP 1701 when you're running L2TP across an IP network. You can run L2TP across frame relay. You can run L2TP directly across ATM, and many people have done that. But when you're going across an otherwise IP network, you use IP and UDP for encapsulation, right? So we get down to, okay, what does this mean? It means basically that your application data is here. Well, your original, right? You get assigned the address that you're going to use, right, as your internal IP packet, or you're routing traffic through the tunnel. So this is your original IP packet with your internal IP, in the case of a remote access client. PPP, I believe it's a 1 byte PPP header. So it's actually very small. L2TP is 8 bytes. It has session identifiers and a variety of information that it requires 8 bytes. UDP, by definition, has 8 bytes. So you've got 8, 16, 17 bytes to basically do all of these scenarios for tunneling. That's why it's an extremely capable protocol. There's something to invest in that solved all these different scenarios, and certainly for us, enabled us to get off of PPTP. L2TP was it. So this doesn't provide encryption unless we were going to do PPP-based encryption right inside here. So the VPN server, because of that first scenario that I showed where clients, there are actual real PPP clients that are coming into a VPN server, the VPN server will accept PPP encryption if it's negotiated by the client for packets, because the PPPs, the IPSec protection may not actually be going all the way to the client. And the client may request MPPE anyway. But by default, we won't use MPPE encryption if the client knows that it's going to be IPSec protected. And so in L2TP and Windows 2000, we don't have a way of doing L2TP without IPSec, because L2TP without IPSec has no security model, right? So, or at least has only a user authentication. So in Windows 2000, we always use IPSec to protect L2TP. And in the case of a VPN tunnel, all of the tunnel control messages, all the tunnel establishment, the fact that it is a tunnel, it is an L2TP packet, is completely hidden because everything is encrypted for this entire blob. And that's using IPSec ESP. We have a bunch of options which will support. It's up to the gateway to choose. There's some client options that you can require encryption and things like that that are synonymous with the PPTP settings. But this is what's happening. Now, the impact of this, right, is that instead of PPTP being an IP and GRE packet, and GRE has session identifiers, right, if you're going through NAT, right, NAT now doesn't see the UDP headers. It doesn't see anything in here. So a network address translator that's trying to translate this, in fact, cannot translate even the IP header because of the way it's integrated in with IPSec by design in the RFC. So the IPSec working group just punted on the whole question of NAT traversal so far. They are now trying to entertain a standard for NAT traversal, and I'm one of the co-authors on a proposal that hasn't been published yet, but we'll basically be having that discussion in Minneapolis in March.
Just so I understand what you're saying. So when you're using this,
NAT is not an option. It's not an option because the packet on the wire looks like a regular IPv4 packet, but it's got an ESP header on it. So NATs can't translate this. And remember, first there was an IKE negotiation, okay, that took place first. IKE negotiation was on UDP port 500. It turns out that because of the embedded IP addresses inside the IKE encrypted negotiation, NATs can't even translate that, okay?
I heard there's one implementation by Cisco at this point of a NAT transparent IPSec implementation.
Right. Right.
Right, but at this point it will be non-standard.
Right.
Are they working with you? Is that the standard track? Are you working with them on that?
Yes. The answer is yes. The problem is that in order to get NAT traversal, I mean, a lot of the VPN vendors just had to cook up something. And they wanted to go to market very quickly. I mean, they didn't want to wait for a standards process. So they've kind of bastardized the way that they process IPSec on receive, so they can allow the IP header to change. And they do something funky in the IKE negotiation, which allows them, first of all, to do address assignment, because it doesn't make any sense. If this is your internet IP, it doesn't make any sense, right? Or your, quote, private IP. You have to have address assignment. So the only time IPSec tunneling works with NAT is that when you're doing XAuth and IKE config to do address assignment back to the client, internal address assignment back to the client. Then they format the IPSec packet. There's two ways to do it. One is that it's an IPSec packet, and you do something funky on receive to allow the NAT to, and on receive on both sides, on the client and on the gateway, so that you don't mind the IP addresses changing in here. And you don't require the addresses in the IKE negotiation. If you do that, then you'll still go through what's called IPSec aware NATs. There's a Linux masquerade, basically documentation, program implementation that shows you how to track IPSec sessions with IKE sessions in the same way that NAT might handle PPTP. The other and better option in the way the Altiga originally shipped was that they put a TCP port 80 header between IP and IPSec. And they figured, hey, everybody allows TCP port 80 through. We'll just use TCP port 80. We'll make it all look like web traffic. So that's what they did. It's not actually TCP. It's a faked out TCP. But they had to do enough of TCP to do the SYN, ACK, and ACK back in order for some firewalls and proxies to kind of recognize it as TCP. So yes, or NATs. And so they will allow a TCP header, port 80 here. Other people have used a UDP header here. And it looks like, when we all got together and talked about this, that the way that we're going to do it is a UDP header stuck right in the middle right here to allow NAT to process it. Now, I'll be honest, that sucks, because you got another 8 bytes of overhead, but you also have additional session management that you have to map the IPSec SAs to the UDP ports that are being used, and that's not trivial. So we're working out how to do that right now, and hopefully the standard will come together. If you want to see an active discussion, come visit Minneapolis with me. Right. So basically, NAT traversal, you can use PPTP, maybe, if the NAT on the firewall allows you to do PPTP. Or you can use, and again, you could use PPTP with the certificate, user certificate authentication, right? So there is more or less a secure way to do PPTP, but that's only Windows 2000. That doesn't help your down-level client. And in the end, the VPN gateways that rushed to market, it was very interesting. Cisco and Microsoft jointly developed this part of IPSec, not L2TP exactly, but IPSec capabilities overall in Windows 2000. And we also collaborated on the L2TP draft. And we thought we were together, right? And then as the IPSec community matured, you had a lot of very small companies selling VPN gateways, and they had customized this IKE and hacked it, and were saying, yeah, look what we can do, right? And they were basically selling. And Cisco looked at this and said, these guys are beating me in the market, you know, and I don't have an L2TP IPSec solution, and when I do, it's not going to go through NAT because that's how the IETF working group said. That's the standard. So basically, you saw a lot of acquisitions by Cisco and others. Network Alchemy was bought by Nokia, and a bunch of people basically, the whole VPN market just consolidated. And what happened was, because they bought those products, and those products had these Altiga ways of doing things, they ended up doing it that way. So everybody basically threw out the standards approach when it went time to go to market.
Would you recommend doing PPTP research or putting Windows server with public interface with IPSec?
I think that your best bet will be deploy user certs and use that with PPTP, because it'll at least go through PPTP-aware NATs and PPTP-aware firewalls if you have user certs, right? So, yeah. Oh, well, I submitted these slides, so I thought you guys had them all printed out. There's a lot of slides that I have and that I submitted, maybe 200. Okay, I'm sorry. Well, this is good. So they better be on the CD. Okay. All right. So the L2TP IPSec VPN Client, as I said, you can migrate off of PPTP with it to the extent that you can install Windows 2000. IPSec is integrated with L2TP. We'll see how that works. We do require machine certificates because this idea of a group pre-shared key was not secure, and it was, had known cryptographic attacks. At least, it's the same thing, right? You have a password, and they just guess the password. So if you have a weak pre-shared key, this is my pre-shared key or a password or whatever it is, they just guess that. It's a little harder, but they can still guess it. And then a fellow came up and asked me, would we support Kerberos for IPSec authentication between a remote access client and a VPN gateway? And the answer is, no, we don't, because the Kerberos that you know how to get a credential from is inside the company network. And I would never recommend that somebody open to the internet their KDC on the inside of the network so that things could work. So certs were the right way to do it. You securely deployed them to your client, you used auto-enroll or you used manual enrollment in some ways, and now from anywhere in the internet, your client says, hey, I'm a member of the company, is the effective security agreement. And there are ways to get a machine certificate. Okay, so here's the automatic policy. right? This is what most people don't get, and you guys will be so smart when you go back. You'll say, oh, I know how this works. It's a piece of cake. Okay. IPSec is based on filtering. It's looking for packets, right? It's looking for packets to secure. All the packets are whizzing by it, and it's saying, do I need to secure it? Do I need to secure it? Do I need to secure it? And the filter that gets created by the VPN client is source of my IP address, okay, which is the internet IP address. Destination is the gateway IP address, because it already did a DNS resolution, or the IP address was statically configured in the VPN client. Protocol is UDP, because that's L2TP. Right? And source port 1701, des port any is the way the filter is created. And I'll talk about why that is in a minute. The inbound filter is, okay, so we have an outbound filter for when we send L2TP traffic, and we have an inbound filter to make sure that we only receive secured L2TP traffic. So source gateway IP address, destination my IP address, protocol UDP, source port any, des port 1701. Our L2TP client uses always source 1701, des 1701. And that's just our implementation choice, because it's a kernel mode client, and you don't want to have to get into the business of mapping, basically deconflicting user mode UDP port usage. So we just always use UDP 1701 as our source port. What happens is that in the L2TP spec, even though the des port is 1701 that we're sending traffic to, what we negotiate, that is the IPsec security that's negotiated, is negotiated for source 1701 dest any, because the reverse of that is the gateway's source any port back to the client. Now this seems a little strange. You're like, well, why wouldn't I negotiate security from my client IP, my client port to the gateway's 1701? So reverse this, from any to 1701. That seems to be the right way to go. And the reason is because the gateway, if the gateway accepted that, then the reverse of that is from 1701 dest any back to the client. Well, what happens is that many gateways, in order to sort of, depends on how they implement, but in the L2TP RFC, they can float their response port. So they don't have to reply back from 1701. They can reply back from 1033 and send back to the client's source port. So what is the client source port? In our implementation, we always fix it to be 1701. If you read the L2TP IPsec security draft, you'll realize suddenly we have the potential for a completely dynamic negotiation. If I choose a port and go to 1701, he chooses a port and comes back to me. Now we have communication across an arbitrary port, basically. Very hard to do, and that's why the security draft is hard, and that's why it wasn't obvious how to do it. When we talked to vendors as we were building Windows 2000, we said, how should we behave? And we decided with the vendors, Nortel and Cisco primarily, that this was okay. And I mean, you have to make an interoperability decision. So we decided that was okay, and we shipped it. And then upon further review, and upon a whole bunch of other people being involved in the discussion, they decided, no, that's not the way to do it. You should change it back, and there's this dynamic filter reinjection model where if the gateway decides to reply back from a port that's not 1701, then it's got to negotiate back to the client and set up 2 IPsec SAs. And we said, oh my God, okay, fine. So that's the way the draft is written. And that's almost the way nobody implements. The way people implement is this way. Okay, so I basically explained that. Win2K's L2TP implementation uses source 1701, des 1701 all the time. And the reason for this weirdness is because the gateway could float its port, according to the RFC. Fine. We wanted to have one client that could work against both gateways. In the end, we found out nobody was floating their port on the gateway, so we didn't support that ability in the client. So we have a little, and now it's there, so we have to support it. Okay, L2TP IPsec client automatically generates the IPsec security rule. As I mentioned, there's really no security settings. There's some data encryption settings that you set, but there's nothing specific about IPsec that you set. And the way this works is that in the VPN UI, I don't know if I still have it up. No. Oh well. If we get time here at the end, we'll probably run out of time. In the VPN UI, you have a data encryption setting. And this setting applies to PPTP if you're using PPTP, or it applies to L2TP if you're using L2TP. If you're using L2TP and your data encryption is require encryption, disconnect if server declines, or request encryption, and it's okay if the server declines, and then there's no encryption, and then there's maximum encryption. So there's 4 possible settings. 4 possible settings for the encryption type on the client. These translate to the encryption settings that are negotiated in the quick mode of the IKE negotiation. So that's there. And realize also, I'll come back. Also so that's the encryption setting on the tunnel. So it's set, but it's set indirectly by your data encryption settings in the UI. As far as the machine PKI configuration goes, let's say that it has 2 machine certs, a machine cert from CA1 and a machine cert from CA2. Okay, maybe it just has 1 machine cert, it doesn't matter, but it could have many machine certs. All right, so if we were doing the encryption, the gateway, the client proposes a list of security methods in quick mode, and the gateway it's up to the gateway to choose which one. But for authentication method, what happens is that the L2TP client looks at the machine store, right, at the time it connects. And you bring up the UI and you hit connect. When you hit connect, it looks at the certs that you have private keys for, right? This is the machine certs in the personal store. And it generates the list of routes that these certs chain to. Because in IPSec policy, you can only specify and negotiate routes, right? So we looked at the credentials that you could possibly authenticate with, built the authentication method, which is, in this case, let's say 2 separate routes, CA1 route and CA2 route. So that's automatically generated when L2TP goes to create the IPSec policy. Okay? After that, it's straightforward, right? Now we know the filter. All right, let me back up before we show the stack. We have a full specification of the policy now, right? We know the source IP, we know the dest IP, we know it's UDP 1701, we got the filter thing worked out. We needed to specify the encryption level, which we did via the data encryption setting on the client and an agreement on the gateway. And the only real trick was, how do you authenticate, right? And the way that we did it was to look at the machine store, the certs that you could possibly send to the other guy, the certs for which you have private keys, generated the off method for IPSec policy in there. Okay, so what's going to happen? The gateway is going to connect. The IKE negotiation is going to happen. You're going to propose certificate authentication. The routes will be negotiated, and then you'll provide one of the CA1 or CA2 machine certs and use that private key to sign the exchange in IKE. Okay. So this is the picture of the stack, which was sort of the other part was an extraction out of. Bunch of things going on in here. Let me just walk you around it. Up top, there's WinSock. Above that, there are other APIs. The multi-protocol router MPR APIs, which are published in the SDK. IP help API is published in the SDK. Both those APIs in the SDK support what's called PF filter APIs. The PF filter APIs actually take effect right here in what's called the packet filter driver. And the reason that I show you all of this is because it's there. And I don't want you to be surprised. When you're looking at behavior and you're trying to understand the way filtering is done in the system, there are several places where filtering is done, and I want to make it plain so you know. Okay, so that's the public APIs for just interface-specific filtering, which are defined, and I think we supported both those in NT4, and we support those in Windows 2000. New in Windows 2000 is the IP hook callout. So in kernel mode, you can write a simple kernel mode driver .sys file that will bind into this interface and be able to intercept packets that go in and intercept packets that come out. That's called the IP hook. There is an unpublished way that IPNAT.sys interacts with the stack. It also sees traffic coming in and going out. And the reason that this little green thing here corresponds to Whistler, this is approximately where the personal firewall is acting. So in Whistler, there's a personal firewall. It's a stateful firewall that allows outbound connections and replies to outbound connections, kind of like NAT, but it'll reject any inbound packet that doesn't already have an established connection. It's a simple one, but it's fairly effective. So personal firewall is enabled right here, above IPSec. This interface point is above IPSec. You don't see IPSec yet. Let me put that in there. So IPSec slides in right here. So all of the IPSec decisions about encapsulation of traffic, filtering of traffic, happen right here, right above IP fragmentation and reassembly. You should think that IPSec is just completely embedded inside TCP/IP. And it's an internet standard for security of IP packets. It's a native part of Windows 2000. We built the feature in Win2K. In Win2K, we actually allow you to just completely rip this out. In Whistler, you can disable it, but it can't be ripped out. It's a part of the TCP/IP stack. It loads with TCP/IP and it unloads with TCP/IP in Whistler. In Win2K, it can be unloaded and loaded separately. So we're trying to introduce something, but we have to do it over time so that people can adapt. By the time we get to Blackcomb, I suspect it'll look exactly like this, and it'll just be part of the stack. So IP fragmentation reassembly is below IPSec because IPSec is defined to work on the full IP packet. So whether it's a UDP packet, TCP packet, or ICMP, or some large IP packet, IPSec works just above it. So all the filtering, permit, block, require security, happen right here. All inbound traffic goes through IPSec. All outbound traffic goes through IPSec. Okay, so fragmented traffic don't go through IPSec filtering until it's reassembled. Now the point down here is that netmon is sniffing at this layer. Okay, netmon is sniffing below IPSec. So if IPSec is encrypting traffic, netmon on that box will sniff encrypted traffic. Yes, sir. Netmon sniffs at layer 2. They know, well, the answer quickly is no. They know about these other interfaces. The problem is correlating packets. So if they sniff down here, which they will see the packet, then it'll come up, it'll be decrypted and look completely different up here. On the outbound, they don't have the interface. They don't have the MAC information that they would normally have down here. So on outbound traffic, they've got to cook up a MAC address to index it in the netmon whole architecture of recording sniffs. And they can't, and then they're going to see that packet again and they can't correlate it. So it's not a simple thing as just allowing netmon to sniff above. The best they could do is have a completely new mode where they only sniff at the top end of the stack out of one of these APIs. But they couldn't get that done for Whistler because we had such a short time. They had to re-architect their whole sniff point and solve the the pseudo MAC problems. So netmon is sniffing down here. What you get in netmon, if you're doing AH, the clear text mode, the integrity only mode, netmon can parse that. So the parser in netmon in Win2K will parse AH traffic. So in fact, when you look at it in netmon, you don't even know it's AH. It just says TCP, UDP, SMB, RPC, whatever it is. Right? You just see it. If you drill into the packet detail, you'll see the IPsec header sitting up there just after the IP header. So if it's AH, you can see it. If it's ESP, no encryption, only integrity, then you'll see the hex data, right, because it's not encrypted. If it's ESP encrypted data and we're encrypting in software, then by the time netmon sees it, it's encrypted. Now the common deployment of IPsec is in hardware offload. So we did it, there's a whole DDK conversation that's documented between the NIC driver and the IPsec driver, and they talk back and forth. And the NIC tells the IPsec stack, this is what I can do in hardware. This is the kind of packets and the algorithms and so forth that I can do in hardware, and this is how many. Okay? So when an IPsec SA is established by IKE, as we've seen before, an IPsec driver is told about the SA, the IPsec driver is sort of the master database of all the SA information. But for the SAs that are offloaded or are done in hardware, the mini port or the NIC driver has the IPsec keying information. So Netmon, if it were sniffing here, would sniff packets which are framed in the IPsec format but are not actually encrypted because the encryption is done at the NIC. Now that doesn't help you too much because the parser doesn't parse into ESP. It assumes ESP is encrypted. But that is an improvement we can make in the parser, is to try to parse ESP packets. The only problem is we wouldn't know whether it's encrypted or whether it's not encrypted. So you could get gobbledygook out of it. So that's the architecture. L2TP and PPP, right? They both appear as PPP dial interfaces. So basically, it looks like a PPP interface from the UI and other tools, but underneath it could be L2TP or it could be PPTP. All right. We see that TCP, remember in the TCP IP Advanced Properties UI, there's some, if you go into Advanced and Advanced, there's connection filters, or TCP and UDP protocol type filters. And those are implemented like way up here at the top, actually in collaboration with UDP and the protocol stacks. They're, I don't know, you can read various articles. IPsec filtering is a lot better. So what happens? When data comes down for an L2TP tunnel, it does a route lookup, right? Routing is done basically right here. The route lookup says this is the interface that the packet's going to go out on. So the packet comes down to that interface. If it's an L2TP or VPN tunnel, it's already been set up. If it's a demand dial tunnel on a VPN server, then it'll hit the PPP interface and cause demand dial to function. Okay, so we're coming down to, we've got an internal packet that's being sent essentially by the application through WinSock, like the, my mail client, sending data down through the stack. It hits PPP. PPP, in the L2TP case, encapsulated with L2TP, forwards it back up essentially as a UDP packet and re-injects back down through those other layers and other callouts to hit IPsec. Now, the reason it's important to understand this point right here is because on a VPN server, when you look at the input and output filters on the VPN server interface, so you can go into the RAS UI, go into routing interfaces, do properties on the routing interface, and see input and output filters on the interfaces that you have in the system. Those input and output filters are implemented right here in the IP packet filter driver. Right? MPR is the RAS APIs, essentially. And that filtering is done right here. So on a VPN server, you'll see permit UDP 1701 instead of IPsec because this guy never knows that traffic is IPsec protected. He sees traffic coming in, it looks like UDP 1701. He sees traffic coming out, it looks like UDP 1701. Okay? So his policy, if he's only doing L2TP, can be deny all, permit UDP 1701. All right, so IPsec sees UDP 1701, it encrypts it, and the rest we know. Right, it goes out, and it'll be offloaded if the network card that you're running on supports it. Which incidentally, I found out that both Intel and 3Com have they're not wireless cards, but they're just 10100 PCMCIA card bus cards. So you don't have to have a desktop PCI card NIC in order to get hardware acceleration for VPN clients. As long as they don't have them on wireless cards yet, but they could. It's just a matter of them implementing. Okay? So notice the personal firewall, when you see that in Whistler, when you get beta 2, the personal firewall will see the outbound packet right here as a UDP packet, allow that connection out. Right? The personal firewall will not see the IPsec traffic because the IPsec is done below it. And in fact, this is kind of, you can combine these filterings in a rich way to get exactly the behavior that you want. You may not want to combine them, but it's certainly possible. Okay, so here's a kind of a diagram of what was going on. The application, so we wanted to deploy IPsec fast. We wanted you to be able to secure your network immediately, right? As long as you had a Windows 2000 environment, and we realized that it would take time, but over time, a Windows 2000 environment will be there What we didn't want to do is force you or any other application to be IPsec aware. That didn't make much sense, right? You as an administrator can set the security policy to say this communication will be trusted, this communication will be encrypted. So we implemented the architecture sort of bump in the stack that Raymond mentioned earlier, right there in TCP IP. So all the traffic from TCP IP gets passed to the IPsec driver, and then the IPsec driver, if it's going to secure traffic, if it permits and blocks, it does it a local decision, right? But if it's got to negotiate security, it'll call up to IKE, and then it will negotiate these main mode and quick modes that we've gone into detail. Okay, the guy that starts the negotiation is called the IKE initiator. The guy that responds is called the IKE responder. This role will reverse throughout time, because the RFC says that at any time, either side is allowed to rekey. So the responder could decide, oh, in an hour, I don't care what lifetime you sent me, in an hour, I want to rekey. So it'll just rekey, which is one of the reasons why stateful filtering in firewalls is not easy to manage for IKE traffic, right? You can initiate, you can control who will initiate the very first initiation, but then you can't depend upon anything in the IKE packet to look at it and say, oh, this is a connection going from outside in versus inside out. Okay, because IKE by definition essentially can go both ways at any time, except for the very first time somebody's got to send the first packet. All right, and then we set up the two IPsec SAs in quick mode. Once we have synchronized the two, and it's not a perfect synchronization because these messages, of course, can get lost, and somebody doesn't, the very last message, of course, can't be ACKed. And you don't want to deny service just because you drop that one last packet, right? There's no ACK for it, so how does the sender ever know that you got it? So it's not a perfect synchronization, but it's a best effort synchronization, which even on 100 megabit and, I'll say 100 megabit networks, we don't see any problems in terms of the timing of how this happens. Certainly on the internet, that shouldn't be a problem. So the IPsec driver then sends out the protected traffic. And so we started out with TCP, UDP, ICMP, whatever it was. We end up with traffic on the wire that is either protocol 50 or 51 plus UDP 500 traffic, right, to set up the SA. And text to explain that. Okay. Raymond, how are you guys on demo? You guys have demo? Not yet? Okay. Yeah. So I'll just go ahead and try to finish up here. All right, so this is a picture of the VPN client. When you first create a new VPN client in Windows 2000, I've entered in a username, and there's some noticeably long password with a logon domain possibly. And we've kind of seen this already, where on the tab that has the networking tab, you can choose PPTP or L2TP. By default, it comes up in automatic mode. We felt that choosing one or the other was kind of too geeky for most regular users. What we do is default to L2TP if you have a certificate. So if your machine is able to authenticate itself, then we'll try L2TP. If it's not able to authenticate itself, it clearly is no point in trying IPsec. So we'll just do do PPTP, unless we're explicitly configured for L2TP, in which case you'll fail. I mean, you'll get a message back immediately saying you don't have a cert. Okay? So the way this works, just to remind you, is the very first thing out of the box for a VPN connection, you never see UDP 1701. It's all IPsec on the wire. The IPsec IKE negotiation with certificate auth, and then the IPsec SA establishment, right, for UDP 1701 between the client and the server on their internet addresses. Okay, now notice the VPN server didn't have to go anywhere. If it was doing CRL checking, it could have gone and checked the client's CRL, or the client could have checked the CRL, the revocation list for the gateway cert. In our implementation, we don't check CRLs because CRLs are not widely or easily deployed. So they're off by default, although you can turn them on with a reg key. Okay, so then we start sending the L2TP session establishment. And if you know much about the L2TP protocol, it's the session request essentially would be the very first L2TP packet. That's the very first L2TP control packet. It goes across the IPsec encrypted SA. Okay? This is a big difference from PPTP. It's a big difference because the control of PPTP tunnels is all in the clear. You can see it. And in some cases, you can modify it. You can potentially manipulate it, as the gentleman suggested, in terms of proposals and encryption methods. I'm not an expert in that particular aspect of the PPTP protocol, but I know that in L2TP, all of the control channel is completely set up, and that's what the L2TP security draft specifies. The whole reason to set up IPSec first is everything about L2TP's operation is protected by IPSec. Okay, remember L2TP is doing user authentication. Typical gateways will do a radius client over to a radius server and authenticate. In this case, back show an Active Directory running the radius server. We ship Internet Authentication Service, which is our radius server. It'll work against other radius servers too, of course, and other gateways can plug into our radius server. Doesn't matter. Yeah. It's actually a radius server. I'll say it's sorry. It's if the VPN server is a member of that domain, then it doesn't have to do radius. It can just do user-based logon by virtue that it's a member of the domain. It can do LSA logon user. Well, what I'm showing is that the communication to the radius server is communication to the radius server. Our radius server backends to the Active Directory. I don't remember whether our radius server can back into some other directory. I believe that that's possible because the radius server has a lot of extensibility. It has a tremendous number of APIs, and you can hook into every aspect of the radius communication by writing custom code on the radius server. So we actually have, the radius server scales extremely well. It's one of the, as I understand, I don't have any data to back this up, but I understand it's one of the best in the industry from the big ISPs that are using this. And certainly we use it. It supports a lot of attributes, a lot more attributes than some. Okay, so the point here is that no traffic gets into your network, okay, until a bunch of things have happened. All right, your IPsec SAs have been established that required strong PKI trust, mutual trust between the client and the gateway. Right, the L2TP user was authenticated, which again, the whole control channel was protected by IPsec. You know, PPP in this case could use CHAP or MS CHAP in the case that the gateways don't support MS CHAP v2 because it's all encrypted by IPsec. So you're not really worried about password guessing on the IPsec packets, right? L2TP can use EAP to authenticate the user with smart cards or a token card for two-factor auth of the user itself. And then, of course, the radius client permits on the gateway permits you to do just about any back-end user authentication scheme you want. Our radius server has, and our Active Directory on the user account has the ability to enable or disable remote access on the user account principal in the directory. So you can deny a whole class of users from doing remote access. In fact, it's off by default for the user account. You've got to enable it. The radius server has a whole bunch of policy that can be implemented in the radius server. So if, in fact, this has been done with a Netscape, an NDS directory. They back-ended it to an NDS directory because what they did is map a bunch of NDS user accounts into remote access groups. The remote access groups are represented in the radius server, and the user is basically identified as a member of that group. They have a bunch of static filters. They have a bunch of static routes that our radius server supports attributes back to our VPN server or any other VPN server that would support those radius attributes. So through radius, you can deliver static routes and static filters back to the VPN gateway to restrict exactly where that user is allowed to connect. And that enforcement would be on the radius server. Sorry, on the VPN server. Okay? So there's basically what I say, user access control policy, which can be implemented on the radius server and at a crude level, deny or permit on the domain controller. All right, so probably, and as far as I can tell, the strongest, if not the most equivalently strong remote access client in the industry. The fact that we support EAP for certificate or smart card user authentication on top of all the rest of this makes it, as far as I know, the strongest. Right? Doesn't mean that you'll always use it in the strongest mechanism. The downside is this won't go through NAT, okay, which is the deployment issue that we're currently working on with this UDP encapsulation of IPsec. Okay, no NAT. All right, if you want to scale this, all kinds of VPN servers all over the world, like Microsoft has, and all your clients VPN in, they go back against a central radius server that gives you all kinds of auditing and access policy that you want to do for your users. Okay, that's the dial. All right. Raymond, I think, mentioned earlier that we don't recommend IPSec tunneling. IPSec tunneling by the RFC doesn't do remote access, right? It doesn't have user authentication, doesn't do address assignment. So L2TP is the way that we recommend to do remote access. However, gateway-to-gateway tunneling, we would still recommend to use L2TP, at least with our product, because you can more easily manage L2TP in the UI. The routing remote access snap-in was built to handle basically demand dial interfaces and the PPP-based VPN interfaces. When we added IPSec tunnel mode doesn't appear as an interface, right? It's a filter. What goes in the tunnel is a filter decision. I think you had asked that, or one of you over here. So remember the stack picture where traffic came down and hit the IPSec layer? If it needs to go in a tunnel, the tunnel happens right there. No interface, just a filter decision about what goes in the tunnel. Right? There's a route lookup which says what interface, physical interface, to send it out of. But there's a filter decision that says, where am I going to encapsulate this traffic to? So you can have a two-interface box, essentially, and yet you can be tunneling traffic, for different subnets all over the internet. Right? And we recommend well, fine. Does that make sense? So L2TP is a PPP dial interface. It's a routing decision as far as what goes in the tunnel for gateway-to-gateway type of tunnel. So you have to manage the routes. For IPSec tunnel mode, it's a filter decision as far as what goes in the tunnel. So you have to manage the filters. Routing is the same. It's the external interface. Okay? You can ask me questions. All right, that's it.
Real quick question.
Yeah.
For policy deployment, you've got, say, 4,000 users.
Uh-huh.
How is there a way to automate policy deployment to the workstations, the end nodes?
Yeah. Here's, I'll just walk you through this particular picture, which is the intro to my next slide. So with Windows 2000 and the VPN capabilities and the IPSec capabilities, this is everything we can do. We can do remote access, right, through PPTP or L2TP. We can do site-to-site, branch-to-branch tunnels using a Win2K server as a gateway, and of course it interoperates with everybody else. For internal clients that are members of the domain, you have Kerberos trust, right, when you're inside the domain. You have group policy configuration from the directory. Group policy configuration would tell the client to go get a cert, for example, from a particular CA. So that's the way that that's the easiest way. If you have an MSCA, like it says up there, if an MSCA inside your network, you can assign group policy to say, go get a cert from that CA. And as I said, for 90 days after Whistler, we'll be able to have third parties do this auto enrollment, but we don't have it yet.
What about for the IPSec, say, parameters, the ICAM?
All of that can be delivered via group policy. The only thing that's not delivered via group policy are the L2TP settings, which are basically hard-coded in the L2TP client.
In fact, the demo we're going to show is how to do that.
The policy?
Yeah.
Okay.
Show how to configure.
Okay.
Take the breakdown next to the
Yep, let me, okay. All right, well, let me just finish this slide and I'll be done. All right. All right, so with auto enroll, you can go get machine certificates. If you didn't have if you had some other third-party PKI, then you could do manual enrollment of machine certificates via a browser login or via manual PKCS10 requests. Okay, typically in the enterprise, your web proxy traffic would not necessarily be IPsec secure, but you can finally, with Windows 2000 and IPsec as a standard, secure every bit of other traffic. Okay, at least unicast traffic, not broadcast or multicast. But all unicast traffic in your enterprise, so you can secure those servers all you want, right? And that other server is intended to be any other Unix or other IPsec capable system. Okay, for Active Directory replication, a lot of times these sites, they may have site-to-site VPN tunnels, or they may just have firewalls and be routing this traffic across the internet. And the big question is, how many ports do I open up for Active Directory replication? The answer is 3, or 2 ports plus a protocol. That's IKE and IPsec. Okay, so I would recommend. I mean, if you're running directory replication across the internet, just put IPsec between the DCs. Right? I mean, that's a secure way to do it, and the firewall will then have a very simple rule, which is to allow only IPsec through. All right, and then finally, we couldn't just solve the internal security problem, right, inside the network without also having a mechanism for remote access clients to be able to do end-to-end through their VPN tunnel into the corporate network. Because this guy's locked down, right? He's IPsec secure. He's not going to speak to anybody that doesn't know how to speak IPsec. So what's the answer for VPN clients? The answer for VPN clients is they have to have a way of, first of all, they can send IPsec end-to-end through the tunnel. And because this guy had a cert, most likely, or he's a member of the domain, right, he can do IPsec through the tunnel the same way, once he's connected to the network via VPN, the same way he'd do IPsec to the server as if he were virtually on the inside of the network. So we basically have tried to take the full picture of connectivity, secure connectivity, and solve all these scenarios in one release, which is why it took us 3 years. And we use this internally all the time. I can't say that it's widely deployed internally because it takes time to understand the policy and to secure these servers and migrate the applications to Windows 2000 and stuff like that. But it's possible. Yeah. Okay, let's break.